John Savio is Vice President of Public Sector for Black Duck. John, welcome. Thanks for joining me today. A lot of discussion here about speed to capability. How have you seen organizations in the sea services or the military more broadly drive speed to capability, getting both of them right at the same time?
Sure. Francis, thank you for having me today. Most weapon systems and capabilities that are being deployed right now in the Department of War are software-based. And from my experience, what I've seen is the best way to speed capability of the capability to the fleet or to the field is through early testing with highly precise tools that provide the kind of feedback to authorizing officials that they need to grant the authority to operate. One example would be, for example, the Naval Information Warfare Center has been able to achieve a continuous authority to operate in their overmatched software armory using Black Duck testing tools. And that software factory is the only factory right now in the entire Department of War that has been able to achieve a continuous ATO. So that's really just the beginning. Other ways to speed capabilities to the field or to the fleet would be through the use of AI-augmented software development. I'm sure you've heard quite a bit about that. So this is something that the Department of War is very interested in, but the next question is, how safe is it? And my thesis would be, we could take AI-augmented software development and make that safe, like Black Duck made the use of open source in the Department of War software supply chain safe over the last 15 years, for example. So the idea is to really control the prompt returns that are coming back when a developer puts a prompt into an AI coding assistant and they get a snippet back for their specific purpose, is to scan that, make sure it meets security, quality, and safety requirements, and then allow that to be pulled into the stack. Other ways of really making AI safe in that context would be to look at the current bill of materials that are produced out of the software that is a part of, let's say, an end item deliverable, and that not only just looking at, okay, here's my list of open source, my bill of material with my security vulnerabilities and my license obligations, but look at, this is the code that was generated by AI augmented software development, and marking that specifically, right, so we understand the risk associated with it. And then providing feedback as to the risks associated with the large language models that actually provided that code. For example, is this specific LLM susceptible to poisonous training, for example? Or has this large language model conducted learning in a way that is not productive for the end user? Another way is to really understand if you have an end item deliverable that incorporates a large language model as a part of its function, to track that large language model, understand the risks associated with it, and whether it's evolving in the right way. So these are a few ways that you can speed capabilities to the field or to the fleet much more quickly with AI augmented code development, and do so safely.
Yeah. The acceleration of all the things that you just described is fascinating to me, because I read an article this week that code development, the code development component of software development is radically different now than it was a year ago, and will be radically different a year from now than it is today.
Yeah.
How does that inform the way that you and others, and then folks inside the building, should think about what they're building today that may not be ready for deployment in 6 months, and yet will be deployed then into a radically different AI environment, a radically different development environment?
Well, I think with the advent of AI augmented code development, the first challenge that one would encounter is code bloat, right? And if you're increasing the amount of code that is in an end item deliverable, any testing capabilities that you're currently using have to scale to that volume of code and be able to get the results to your authorizing official just as quickly as they are now, right? Even though this volume of code has increased. So to me, that is probably one of the biggest challenges with these AI augmented tooling situations. Right now, I see the number of developers that are actually working on code potentially going down because of AI augmentation. So then it becomes, can they handle the volume of code and the volume of results that they're getting, right, from testing? And then how can we use AI to curate those results, right, and provide them remediation advice that they can trust? So those are some of the implications that at least I'm seeing right now, but who knows what may emerge.